Go for it.
Good morning, good afternoon, or good evening, depending on where you are. Welcome to another in the Perspective series of webinars from AirInsight. Today, we're going to have blow our own horn a little bit, talking about our decision analytics products to give you an introduction to that. Today, we'll have a few samples of some of our decision analytics models that Addison will go over with you. Show how these can help you better understand the industry. Flight operations will have models on the fuel costs, stage length, on-time performance, city pairs, delay costs, a number of examples of how we can use data and data visualization to help explain, answer questions in the industry. And we'll provide a Q&A opportunity for everybody to ask Addison some questions about these models. He's the expert on the various databases that we have, and we've probably got a dozen or so that we use and integrate together for these types of analyses. I'm Ernie Yarvey, president of AirInsight. Those of you who've been on before know me, and those who haven't, I've been around the industry for more years than I'd like to admit. Addison is our key presenter today. He's a partner in AirInsight Group. He's been doing research analysis and consulting for over 30 years. He's a native of South Africa, got his degrees from the University of Cape Town, and we can call him Dr. Shanlon since he got a DBA from Rushmore. Addison is our prime panelist today, and I'm going to turn over the screen sharing to him and stop my screen share because he's got to bring up the models and be ready to go with that. Addison, it's over to you.
Thank you, Ernie. Can you just everybody confirm that you can see the screen? Ernie, you can see the screen?
You can see your screen, Addison.
Okay, great. All right, let me just echo Ernie's welcome. For those of you for the first time, welcome to, thank you for spending time with us. And for those of you who are on a repeat visit, glad to have you, delighted that you're still interested in what we're doing. So what I want to do is to start off here is show you that if you go to our website, I'm just trying to admit people into the room at the same time. If you go to our website, you'll see up here, Decision Analytics. There's an About page that if you're a subscriber, you have access to a whole bunch of things. There's a public access and there's media access. If you're a member of the media, you click here and you can see all kinds of models. So if you go to public access, this means anybody is allowed to look at these models. We have a little video here that talks about a model. And then we have the Airbus O&D, Boeing O&D, transaction tracker, and US airline metrics. The Boeing O&D, by the way, I don't know if any of you have noticed, but Boeing has changed the way they show the commercial orders and deliveries as of the last couple of days. It's now a data visualization, and it's going to be very interesting to see how any of us can download their information and model it, because it seems to me they look like someone's trying to hide something there. Anyway, the transaction tracker is a very interesting one because it shows you the commercial and government airplanes that were traded in a month, and it goes back to 2017 January, and we update that once a month. So in the next week or so, we'll be updating it again. Then over here, we have the COVID trackers. We have domestic flight model, an activity flight model, daily flights with load factor estimates. This one's quite neat. Just let me show you this one. This is basically the start of the pandemic. Over here, we were down 3 days in a row, on average of 11 passengers per flight in the US. And then you could see there was a great rise in the number of flights. There was an anticipation of a recovery that was much faster than actual passengers. And the flights grew here, the passengers grew there. There was a confidence, and then there's been an adjustment as everybody's getting better at where we are. So those are the kind of models that you could look at on the page. And if you're a subscriber, like I said, you can see more. So the first model I want to share with you is a fuel cost model. In this particular model, we're using data from the T2, which is a US Department of Transportation source. And what we have here is fuel gallons per seat mile and fuel gallons per aircraft mile. I take it everybody can see this. I'm not hearing any complaints. You can select airline over here. I happen to have selected Alaska. And what we have is an average line for the fuel gallon per seat mile and an average line for aircraft mile. And now we've got 205 to 220, the first quarter. And we can see something interesting when we do this. We can see how Alaska's fleet has performed over the period. You'll see they add the 737-900, and then the Virgin Atlantic fleet gets brought in. Virgin America, I beg your pardon. And what this does, it shows us if you're in this quadrant, you're obviously not in an attractive quadrant. If you're in this quadrant, you're in the most attractive quadrant. This is the lowest of these two. The 321neo, if I click that, you can see that over time, over the period reported, it's getting better. It's going further into this quadrant. If we look at the 737-700 though, it's moving away into the top right-hand quadrant, which is the least attractive place. And if we look over here, this is the 319, moving away. And what we will see is, as we go through some of these models, you'll start to get a feel for which airplanes are good and attractive and which are less attractive, perhaps in terms of fuel burn. In this particular one, we have fuel burn per seat mile again, and this one is average seats. Now you can see at Alaska, the Neo is here with an average of 190 seats, the 737-900ER with 178 seats, and so on. Again, let's click that and see how did Alaska's fleet evolve over this period, this 15-year period, nearly, well, more than 15 years. Again, you can see that's the least attractive corner. This is an attractive corner, and that's where they are. We can go, for example, if you wanted to look at American, and you can see the size of the ball is revenue passenger miles. So that gives you a sense of how big is that fleet. And because American has multiple types, we can select that and say, well, we only want to look at single aisle. Again, you can see where this airplane is. It's in absolutely the best optimal place for that fleet. This one you can see is, over the time, has become less attractive. And now you can see why it's being retired. And what's interesting is this one is replacing that one. But just to see the movement, I got rid of the MD-80s because that's sort of no longer a factor to look at. We see we had the MAX there briefly. So this is a model that will tell us all kinds of interesting things about the way the fleet fuel burn works. Now, here we have a model that talks about fuel burn in a different way. Fuel as fuel as the total against total air ops ratio, percentage terms. So for example, let's say we want to look at the 738, which is a very popular airplane. We can see here each airline, and we can see that dotted line is a trend which shows us that clearly the airlines have become much more effective in the use of fuel. There's no animation here, but we could, for example, select 752, and you can see fuel was still getting better, but perhaps look at these ratios here, not as attractive. Let's look at the MAX. Not a reliable number because, of course, we don't have enough data. And this jump here is based on the fact that the data is just too thin. How about the 320neo? Spirit and Frontier are the primary users of that airplane, and we're seeing something very odd here. This one here being Frontier going up and Spirit going down. Next one is the same kind of ratio, but now we're going to look at by airline. Which, in other words, you can look at one airline and its fleet. So here's American, single aisle. And here we can see the MAX jump up, which is obviously nothing we can, statistically not reliable. And we can see again, the trend is down. And here we have a big jump. And if I can click any one of these lines, it'll help me identify just that line, and the others get grayed out of it. This one here is the 321. And obviously it came in and then settled down. let's take a look at Southwest. And you can see here we have the here we have the MAX. They were doing very well with the MAX, and then of course that was a short-lived thing until it starts flying again. The 717, then they briefly had them when they bought AirTran. That was a very short period. And we can see here again the consistencies in the trend of downswing in fuel use. And then finally, we have on this particular model some data points for those of you who like to look at actual hard data. So that's where we are there. And that's the fuel cost model. I should point out, we have somewhere between 30 and 50 models altogether. And every time we work with somebody on a model, we benefit from that as much as they do. It's a very iterative process. It's one where we're constantly learning new things because it's very dynamic. The next one I want to show you is stage length. Now let's go to the beginning. And this one, again, uses the T2 as a source. And what we're looking at here is you can select an airplane. I have 321 selected, the years, the airlines operating that airplane, and the average stage length the airplane is flying. Now, stage length is an interesting thing. When you see the US airlines buy airplanes, almost every single time there's talk about transcon capabilities. But look at this. The 321 is the 757 replacement, and it doesn't get used. I mean, it's flown transcon, but on average, it's a 1,000-mile airplane. That's what they use it for. JetBlue is making use of it up to 1,800 miles, which is great. But American, Spirit, Delta, Frontier, it's all under 1,200 miles. This is a dynamic, so let's take a look at what happens as the airline industry started to deploy that airplane. And the size of the ball is revenue passenger miles. Now let's take a look. If you would humor me for a second, I'd like to show you something interesting. What happens if you go to the 321 Neo? Remember we saw 1,000 miles? Now look at this one. This is a whole new ball game. Hawaiian is the king of the hill in terms of getting range out of the airplane. Stage length typically is 2,400 miles. Alaska is using it successfully. American, 1,600 compared to the 1,000. And we can see here what's going on. Obviously, not much data because it's quite new. By contrast, let's take a look at 738, which is a rock-solid airplane used across the industry. Look at Alaska. Nearly 1,800 miles is an average stage length for that airplane. So they really make it work much harder than everybody else. Now, to give you an idea of how neat this is, if I click on United, what we do is we see from there to here what that stage length has looked like and evolved over time. If you look at Delta, 1,400 miles is now back to 1,100 miles. I don't know why they do that, but that's how it's worked. Alaska's been consistently using that airplane for, let's say, close to 1,500 miles to 1,800 miles. They fly a lot longer legs with it. American, very strange. It would, at the average of 1,300 miles or close to the average, then it came back. They do a lot of service with the airplane, but it's back to a 1,000-mile airplane. Very interesting stuff. And again, we could spend a long time on these, and I don't want to bore you because I know watching data sometimes is like watching people's vacation pictures. If you weren't on the vacation, it puts you to sleep in about 5 minutes. Here we have another thing where we have stage length and models across the top, and models, here we have stage length by number of flights. The size of the ball is RPM, and let's say single aisle at United. Now what we're going to do is see all of United single aisle airplanes and see how they behave. And we can remember they merged with Continental, so you'll see, there we go, the Continental merge occurs. And you see all these new airplanes coming in. Interesting thing here to see at United is that the 737-900 and the 738, look at that. That's a 738, and here's the 739. They use that airplane interchangeably. Different gauge airplane, but they use it very much the same way. The 753, small fleet. 752 was a huge fleet, but as the balls get smaller, you'll see it's carrying less traffic. Obviously, what we would like to see is what they're going to do with their 737 MAX 9. And we can see already that that airplane was coming up for 1,500 miles on an average leg in 2019. How about the regionals? Well, we have some information here too. Again, let's start off with just show you that we do have the numbers, but let's take a look at the CRJ-9, the Mitsubishi airplane nowadays, and see how that airplane was deployed. Size of the ball is the number of revenue passenger miles. Obviously, some of these guys went out of business. Now, what I want you to focus on here is look at the range of the mileage over here. This is the typical average stage length. This airplane is typically below this number here, which is roughly, let's see, this is 550 miles. If I say, let's take a look at how is the 175 being deployed. Look at that, much longer ranges. And this is how the 175 has been doing, and you can see why it became, or it has become the benchmark regional jet, capable of a lot more than one would think. And now, again, let's look at SkyWest, for example. A lot of traffic on that airplane, and they typically have used it up to 800 miles. It's now back to about 643 miles. Now, I wanted to show you something back here at the CRJ-9. When SkyWest used the CRJ-9, they were using it up to 900 miles. But they brought that airplane back from that range. Data visualization doesn't always give you the answers, but it helps you ask a much more pointed question. And I think that's the benefit of that particular visualization in terms of the stage length. Now I want to show you a couple of on-time models. The first one I'm going to use is the flight planner. Very pretty colors here. What we have is from the on-time database, we have the block times when the flights are supposed to arrive. We have the airlines across the top. Now, here's the thing. Typically, an airline can reset its schedule overnight. So everybody should start in the green in the morning, right? Well, you can see that some guys start more in the green than others. Southwest has got a fantastic, this is 2020. And let's go to just to 2019, which was a full year, and a better way of showing it. Southwest starts off an average of 3-minute arrival delay, ends up the day at 18 minutes. And as the day gets longer, they start to run late. JetBlue runs late really quickly. By 2 o'clock in the afternoon, they go into the red, 26 minutes late on average. United typically around, let's say, 1500, they start to run into trouble, but they seem to make back that situation late in the evening. Frontier, 4 o'clock in the afternoon, they run into schedule problems. American, around 5 o'clock. Now, what we can do with this particular model is, let's say we would like to see from, let's figure, Atlanta to, let's go with Chicago. Atlanta, Chicago, that should be a good one. So now what we see in Atlanta, Chicago, the model automatically says, well, only these airlines are flying in that market. And you can see Spirit has very few flights. That particular one in 2019, the 8 o'clock flight ran into some difficulties. Southwest has several flights and they run into some sort of a problem. Delta has several flights and they run into a slot problem at noon, late at night, and dinner time. American only runs into problems at 6 o'clock. And the nice thing about this particular model is that if you're using this for we call this one the flight planner. And the reason is because if you are booking tickets, this is a nice thing to be able to use for a city pair to see, well, what should I expect? And the bottom line is, from what I'm learning from this, is that if you're flying anywhere, leave in the morning. That's the best time of day to fly. Just leave in the morning. Next model I want to show you is City Pair. Now, in this one, it's also using the on-time data source, but here we have the reservation time, elapsed time, and what we're looking at is Atlanta to Dallas. And those are the years, 16, 17, 18, and the beginning of the first quarter of 20. As far as I'm aware, Atlanta and Dallas, Fort Worth have not gotten further and further from each other. The distance is the same. But look how the time has gone, 145, 145, 145, 44, now it's up to 150. But the actual elapsed time flying is 138, 139, 140, 140, 148. And this is what the difference between those we call padding. For those of you in the industry, this is obviously something you've heard of before about padding. And you can see that some guys pad more than others. So just to be sure that we're going to be fair, let's look at Baltimore to, well, let's go Baltimore, Dallas. 207, 207, 209, 208, 221. That's crazy. And it's Spirit that's really pushing that number up. 8.6 minutes padding, 10 minutes of padding last year, 9 minutes the year before. So these tools are, let me just see, is everybody, oh, I need to let people in. 1 second, please. Okay, I'm back. These models are very interesting from the perspective of travel planning. And then the last model I'd like to share with you is something that we've been working on. It's kind of new. And what we have here is we're doing something really unusual. We've combined the Form 41 5.2, the T2, and we used the Flight Radar 24 active fleet to get a sense of who's flying by tail number. And here we have airline name and the year 2010 to 2020, model of airplane, 2010 to 2020, and the chart below will reflect what we see above. And you can see we have some outliers here, Hawaiian, and it was the Hawaiian 321 Neo that had to settle in. But essentially what we see here is we have been able to calculate what we believe is the estimate of what does it cost Alaska Airlines to run on a cost per minute basis, 64, now they're at 73. American Airlines is at $99 a minute. Delta's at $95 a minute. United's at 74. The industry average is 83. If you were to say, well, what does a 753 cost per minute? 104. This is all based on the delay factor of delayed arrivals. It's a work in progress, and we can take it here and say, well, how many flights in 2020 did these airlines fly? What percentage of those flights were later than 15 minutes arrival? And what, by the way, was the average delay, whether it was 15 minutes or not? And we can see, although 14% of Alaska's flights were over 15 minutes, on average, the delay is 8.5. Based on the cost per minute, we estimate that this is what a delayed arrival cost is for that airline. If we stick with the 15 minutes, again, the percentages, and how much money do we think these airlines have been losing from late arrivals? It's a big number. That's $96.7 million. That's a lot of money. If we, here's another animation, and here we say, well, delayed arrival costs, all airlines, all years. So we can go like this and see what happens. Now let's go to 2019 because that was a full year. What you see is the 321, the 737-700, the 320, and the 738. Those airplanes carry the majority of the traffic. So you would expect them to be the airplanes that have the highest cost associated with delays. If we look at this from an airport point of view, and I've got JFK selected, we can select any one here. Here are the years that average delayed arrivals at that airport. These are all domestic flights, by the way. Percentage delay of flights, how many flights? What is the airline operating cost per minute? And what do we estimate that cost is per flight? So a typical JFK flight this year is $1,820 for a delay. And if we look at it from an airline perspective, I've got some United selected. Here we have the reasons for the delay. You'll see late aircraft arrival is by far the largest. There's also air traffic control delays, the number of flights, the elapsed time for that flight, what is the average arrival delay, the percentage delay, and then what do we believe the costs associated with those delays were. So that is a quick walkthrough to share with you some of our models to give you an idea of what we've been able to build. So back to you, Ernie.
Thanks. Thank you, Edison. Let me find my mute.
Okay. You're on.
There I am. There I am. I'm unmuted now. Sorry about that. It took a little while to find where we are. So we can open up to questions and answers at this point, and talk about the models in more detail, how to access them, and what we do with them, and some of the insights that we have seen in the last year as we've been building these models and refining them. Edison, you did a story just recently that utilized some of the modeling data. I don't know if you want to talk about that a little bit, and
which one was that? There are so many. I don't know which one to. Was it the number of employees?
The employees. That was an interesting one.
Okay. Let me see where that would be. 441, I believe.
Yeah, we're all concerned as Congress is dithering about whether to provide more support for airline employees, and we decided to take a look at what the industry would look like if no aid were forthcoming, and what airlines would need to do to adjust the size of their staffs. And the results were quite telling. I don't know if you can dig that one up, Addison.
Yeah, I think here we go. So what we have here is we're using the Form 41 T100 traffic model and the Form 41 1A. Those of you who are familiar with these data sources. So
share your screen.
Oh, I'm sorry, I forgot to do that. Thank you. Okay. Can you confirm when you see that?
Yes.
Okay, fine. So this light blue line is the number of passengers per flight. And you can see things were going great guns, and then it fell down. The dark blue line is the number of employees per flight. And so obviously what we want to look at is ratios. And what we see is the crossover point is over here, where, as you can imagine, all hell broke loose. And what we see is the number of employees per flight shot up because the number of passengers dropped down, and everything. That's where our industry went totally out of what was looking like a great scenario. So, for example, how did Alaska Airlines look? How did Allegiant look? And you can see Allegiant was still doing okay. And I think that the evidence out there suggests that Allegiant is still doing better than anybody else. American, serious crossover. Delta, also serious crossover. Frontier, they should be doing okay. I noticed this morning that Flight Global had a story saying that the ULCC should recover quicker. Hawaiian, also a serious crossover. JetBlue really got hammered. Southwest, same thing. Spirit, ULCC, they should be doing better than others maybe. And United, another serious crossover. So when we look at the combination of this and we say, well, how are we here? Essentially what we can see is we look at by quarter from 2013 to 2020, this is the number of employees per flight. And this is the forecast of what it should have been. But of course, absent all the traffic and all the flight cutbacks, the ratio went that way instead of going this way. And what we saw in the second quarter of this year is that where we should have been around 70 to 80 people per flight, we shot up to 783. If you wonder why the news out today about American talking about laying off 40,000 people and how terrifying that is, now you can see why. The devastation is unbelievable. For highly skilled people, for example, if you're a pilot, it's not really easy for you to find something else that uses that skill set. If you're a flight attendant, where are you going to get a job? The devastation is incredible. So let's look at specific airlines. Alaska, they went from 55 in the first quarter to 636. A massive overemployed numbers in the company. American went from 125 per flight to 1,030. It's shocking, absolutely shocking. Delta, 97 to 1142. Now, bear in mind, the second quarter was the bottom of the barrel, right? Remember I said that for 3 days there in March, we had 11 people on average, 11 people per flight in the US. It's gotten much better. We're like 45 now, 48. But still, the infrastructure we have in the US is designed to move 2.5 million people a day. That's the infrastructure. The infrastructure didn't go away. The traffic went away, but the infrastructure is still, by and large, it's there. Even if you park the planes, you haven't parked the people. You haven't parked the mechanics. They're all still there, waiting for all of us are waiting for a miracle for this to come back. But the dislocation is so massive. We would expect the airline industry, 22 to 508, you would expect the airline industry to do mass layoffs. I don't know how the industry can avoid this. And I don't think if Congress could even step in with more payroll, I don't know if the airline industry could handle this. Hawaii went from 38 people per flight to 674. JetBlue, 40 to 634. Southwest, 38 people. Look how efficient they were, to 253. Spirit, 10 people per flight to make that airline operate. Now 119, more than 10 times too many people. United, look at that number if you really want to get an eye popper. And I think that the benefit of the data, the data visualization is that data doesn't have an opinion. Data doesn't care about politics. It's shocking to see the devastation in this industry. And Ernie and I, we work in the silo with all the rest of you, and it hurts. It hurts to see this happening to people. So yep. That was just a one I hadn't planned to show you, but I think it's perhaps the useful thing for like a bit of a cold shower.
We have questions. We have a question, Edison, from the audience. Why does the left axis show 20 and the average of the quarters is 85 on? I'm not sure which chart that refers to, but probably that one.
I'm sorry.
I'm trying to read the left axis there. It's
this one says total employees per flight.
Okay.
So
it shows 20 or so. I can't read the numbers well on my screen.
Okay, I'm not trying to.
Looks like it's below 0 to me at the start, so I'm not.
Oh, okay. This number here was 33. This number here is total employees is 162.
Okay, I'm just okay. I had a hard time reading.
Okay. Oh, I think what people are saying is that says 2604, but it doesn't show that over here. It's a good question. I'd have to look into that. These are it. I don't want to say this is a work of art because it's not, but there is some black art in here, and sometimes we have to keep refining and learning from what we're doing. But every question is a valid one, so it's. I'm glad that people are bringing these up. Either way, you can see that there's a giant jump out of trend.
Yep.
And if anybody, by the way, if anybody on the Zoom today would like to spend more time with me going through this, I would be very happy to do that, because I promise you I will benefit from this a great deal. Because every time we have another pair of eyes look at a model, It helps us make it better.
Okay. We can go to Q&A if there are any questions for Edison from the audience. We can put those in the chat room, and if not, we'll review again how to access the models and where to find them on our website.
Okay.
No further questions. So why don't we reiterate where to find them on our website? And
okay, so if we go back to the website here, you go to Decision Analytics, public access for the free ones. For those of you who are subscribers, there are various models you can look at. For those of you who are members of the media, you have access to models over here.
you need to register with us for that.
Right, and of course you just log in up here. For those of you who have an account, just log in up there, and then you can access whatever you'd like to see. And again, I would like any of you to reach out to me if you would like to go through a model one-on-one, because like I said, I will benefit from this as much as you do.
All right, well, we appreciate all of you attending, and thank you very much for being with us today. Look forward to seeing you online shortly, and we'll be back with the information for our next webinar soon. You'll all get an email invitation to the next session. Thank you so much for being with us. Thanks, everyone. Have a great day.